Okay, the question is this. So it's a continuous like integral of from 0 to pi x f sine x dx equal to pi by 2 integral of 0 to pi f sine x dx. That's what we have to prove, right?
Yeah.
So now let's take this as a capital Fx. So I'm going to say capital F x equal to integral of x time f sine x dx. Right? Now we are going to do some substitution that is already recommended to us. That is u is equal to pi minus x. Now if I derivate this, that is du is equal to, if you derivate that, it's minus dx. Right? Now this also 0 to pi. Now in this case, this is the x equal to 0 to pi. Right? Now if it x equal to 0 to pi, now if you plug 0 here, right? So x equal to 0, then u is equal to pi, and then x equal to pi, and u is equal to 0. Right? Now let's work out this, and we are going to substitute here everything here. Now instead of x equal to 0, I need to write here pi u is equal to pi to u is equal to 0. The x is, if you plug x is pi minus u, right? That is pi minus u. F sine pi minus u, instead of dx, we need to have minus du. You agree with that?
Yeah.
So everything I substitute that now is everything now u now, right?
Mm-hmm.
Now we can see, now we know that integral of a to b fx dx equal to minus integral of b to a fx dx, right?
Yeah.
So you can flip that. So this minus, I'm going to put it here so that I can flip that. All right?
Mm-hmm.
So we'll keep this one in the box here. So that is equal to, so integral of u is equal to 0 to pi. Now because I flipped it, so that now I'm going to multiply this. That is the first one is pi time f. This is actually sine u, because sine pi minus x equal to sine x. That is sine u du. That's the first one, minus integral of u time f sine u du. Again, u is equal to 0 to pi. Right?
Yeah.
Now, what we have here is, we have a, now if it, we know this also. So integral of x time f sine x dx is same as the integral of u time f sine u du. Both are same. Just only the letters different, right?
Yeah.
Now this one I can say this is this here, the fx. So that is my fx now, right? Because x equal to 0 to pi, x fx dx is same as the u is equal to 0 to pi, u fx sine u, right? Because that is also fx, right?
Yes.
There's no difference. So that actually pi time integral of, right, u is equal to 0. Now we can now flip this. How? Because that is x equal to 0 to pi, because that minus will come here, that is f sine x, right, dx minus capital F x. If I bring the capital F here, that is 2 times capital F x equal to pi time integral of 0 to pi f sine x dx, and we get the answer fx equal to, fx is the question, right? This is my fx here, fx equal to pi by 2 integral of f sine x dx, right?
Yeah. Okay.
So I didn't do any integration at all, right?
Yeah.
Good. Now that's for the for this, right? Now we are going to do the second part, right? To part B. This is the part A, part B. Then using that one, we need to integrate 0 to pi x sine x over 1 plus cosine squared x dx. Now this one can be written integral of pi by 2. So the x is here. This is my fx, right? Pi by 2 to integral of, with this formula, 0 to pi sine x over 1 plus dx, right?
Yes.
Now we need to do u, right? So let u is equal to, right? That is cosine x, then dx equal to minus sine x, so du is equal to dx. Now that means this one can be written now in a u, so that is sine u, that is pi by 2 integral of, so let's put that x equal to 0, cosine 0 is 1, so that is u is equal to 1, 2. If I put pi here, that is cosine pi is minus 1, right? Cosine pi is minus 1, yes, minus 1. Then now sine dx, that is this, that is minus du over 1 plus u squared, right? Now what is this? This actually is a tan inverse, right? Let u u is equal to tan theta, okay?
Okay.
Now, so if you do that, du is equal to, if you derivate tan, you got secant square theta d theta, right?
Yeah.
That we know. So that means, now again we need to change this. So that is actually, so I'm going to start here. That is equal to minus pi over 2 from, now if you put 1 here, u is equal to 1, the theta should be pi by 4, right? and if you put minus 1, that is actually, we can say minus pi by 4. 4. Du is secant square theta, 1 plus tan square theta d theta, right?
Yeah.
Now 1 plus tan square theta is equal to secant square theta.
Mm-hmm.
So that is equal to minus pi over 4 integral of, pi over 2, pi over 4 to minus pi over 4, that is secant square theta over secant square theta d theta, that is 1. Now minus pi over 2, now if you integrate 1, that's theta, right?
Yeah.
That is theta from pi over 4 to minus pi over 4. Now that is actually minus pi over 2. That is again, if you plug, that is minus pi over 4 minus pi over 4, right?
Mm-hmm.
And that is plus, that is pi over 2, right? Minus pi over 2, that is plus, that is pi over 4. Is it pi over 4? Pi squared over 4.
Yeah.
Because this is pi over 2, here pi over 2, right?
Mm-hmm.
Minus pi over 2, minus into minus plus, pi times pi square, 2 times 2, 4.
Yeah.
Right? And I would have get same answer, and this I was telling tan inverse, right? That's going to be same answer.
Mm-hmm.
Why? Because if you tan inverse u, you plug 1, you get pi over 4. You plug minus 1, you get minus pi over 4. That's what you're getting if you directly, if you don't know the formula.
Yeah.
So the formula is actually, I think these are the formula you can use directly, right? So make sure that formula is actually this. Integration of 1 over 1 plus x squared dx is equal to tan inverse x.
Mm-hmm.
I look at dry morning, then I go, oh my, this isn't that bad. So the question is now, we need to integrate from 1 to 5 cosine x dx by using a trapezoidal rule, right? So the trapezoidal rule trapezoidal rule, and that actually, what is the meaning is, we are going to make a trapezoid on each things. Like for example, you have a graph here, something like the graph going here, so we make a pieces here and we make a trapezoid. So these all are right. That is the n is equal to, so n is equal to 1, so 1, 2, 3, right? Now we have a I, this is I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3. It's going on. Okay? Now you find all the area and you add. So the formula for this, right? So if you have a integral of, let's say this is the fx dx, sorry, x. Now if you want to figure out the fx, let's say this is a to b, here a to b, that's what we had to figure out. So a to b, fx dx, the same as finding all the trapezoids area and adding together, right? So that means, let's say the distance between these two are, we call it, so now each distance here, we call delta x. Each distance are delta x. That mean and also that a to b, and we have I is equal to 0 to n, here n, last one, right?
Yeah.
Now that formula here is delta x divided by 2, because the 2 coming from half time base time height, or half time, the trapezoid is this, not half time, the trapezoid is this, right? Then let's say this is the we can say P and Q, and this is the H, that is the half time. So area is half time base time, P plus Q time H, right? That is the area of the trapezoid here. Now the half coming from that, and then these are the F, say F0 here, F1, F2, F3, Fx0, right? So we call it Fx0 plus 2 times Fx1 and 2 times Fx2, and the last one is integral of Fxn. That is my integral. Okay. Now in this case, delta x is actually, what? That is b minus a divided by the total number of the division, that is n. Is right? Okay, that we divided it into n pieces, that means each piece is a delta x, right? And the xi is equal to, that start from a plus I time delta x. Is it true, right? Because I is the number of this. I mean, if you add a plus delta x, is the next one. A plus 2 times delta x, next one. A times 3 times delta x. So you get that different x. So this is actually the trapezoidal rule, okay, to find it. Now we are going to use that. So in our case here, this one, a is equal to 1. B is equal to 5, right?
Yep.
And now we have then the fx equal to cosine x. Is it right?
Yeah.
Now we're going to just do that here. Therefore, delta x equal to 5 minus 1 over. Now they are asking, they want to have a 5, what's it called? They want to have a 5 of those, right? 5 equal subdivision mean this n is equal to 5, and the n is equal to 5, right? That's what they want to do. They want to 5 pieces. See now the this is the n pieces, right? N pieces, because start from 0, that's why. So 5 minus 1 divided by 5, right? And that is equal to 0.8, right? Now let's plug into that. That is, so integral of a to b, that is 1 to 5 cosine x dx is the same as delta x by 2, that is 0.8 divided by 2 f. Now we need to know what are the x0, x1, so we're going to figure out that. This is the x0 is 1, right?
Yeah.
X0. X1 is equal to, that is 1 plus 0.8 times, right? So that is 0.8 times 1, right? And that is 1.8, right?
Yeah.
And x2 is again a is 1 plus 2 times 0.8, and that is actually 2.6. 2.6. And x3, right? x3 is equal to, right? You know what? I had to write it in somewhere because I need the space here. So we will write in this location because I don't need this location here. So we can find the x0 is equal to 1 and x1 is equal to 1.8 and x2 is equal to 2.6 and x3 equal to, that is again 2.6 times plus 0.8, that is 3.4, and the x4 again you add 0.8 here, and that is 4.2, and last one x5 is equal to 5, that is this.
Yeah.
Now x0, that is the f1, right, that is the f1, that is cosine 1 plus 2 times cosine 1.8 plus 2 times cosine 2.6 plus 2 times cosine 3.4 plus 2 times cosine 4.2 plus last but not 2, that's actually cosine 5. Right?
Yeah.
So this should give us an answer for us, and that is a 0.4 time. Now if you do that, there has to be radian, okay? Because we don't want to go into radian, so we need to change it to radian. So 4. So here's the cosine 1 plus 2 times cosine 1.8 plus 2 times cosine 2.6 plus 2 times cosine 3.4 plus 2 times cosine 4.2 plus cosine 5. Wow, it takes long. So minus 4.2, how many decimal?
4 decimal.
4 decimal. 2, 5, 8, 3.
Oh,
You got that?
yeah.
So time 0.4 equal to minus 1.7033.
Yeah.
Now, okay, now why is minus? Do you know that?
No.
Now the problem is, look at here, when I draw the graph here, here's the cosine graph. Okay, this is my cosine graph. Now we start, see pi, this is pi, I'm going to write in a number, so that pi divided by 2, that is, this is 1.5, 1.6, 1.57, okay. Now the other one is 1.5 times, 1.5 times pi, that is 4.71, okay. Now the question is, we have to start from 1 to 5. This is our 1 somewhere here. This is 1.5 mean. The 1 is here. This is my 1. And 5 is somewhere here. Now if you look at this, if I figure out the area, this is positive area. This is positive area. This is negative area. Now if you look at this, negative is bigger than these two positive. Now, when you add together, you get negative answer.
Mm-hmm.
So that means our cosine, this
Oh.
value, because here you get probably, I don't know how much you get here, probably 2.5 minus these two. So you get minus 1.703 because of this is bigger than these two here. Because we are figuring out from 1 to 5, right? So that's why we got my negative answer here, minus.
Okay.
Right? They didn't ask you to figure out area. They asked you to figure out 1 to 5,
Yeah.
right? So if they're asking you to area, then you have to figure out from here to here, then you take this area, from here to here, you take this area, you have to add together everything, you get a positive big number, right? But because this will, see, now this will cancel with this, right? And this will cancel with this, and this area is 1 point minus 1.7033. That is this area, right? Because these two are cancelling each other's, right? Then you get this 1 point. You understand this?
Yeah.
And that's why.